Hey everybody, today we're going to take a look at two formulas. One of them is the midpoint formula and one of them is the distance formula. So what we're referring to is the midpoint or the distance between 2 points on a graph, okay? So we're going to start with the easier idea, I think, which is the midpoint. We want to find the middle of 2 points. And when we find the midpoint, what we will be finding is literally a point. Remember, how do we name a point? A point is named with 2 numbers, the x and the y coordinates, okay? So we're going to find the middle of 2 points. Let's think about finding the middle of 2 numbers. You may have done this in your past academic life, right? The middle of 2 numbers is the same idea as the average of 2 tests. So for example, real easy, if you got an 80 and a 90 on your first 2 tests, you know instinctively that your average is 85 because 85 is the middle of 80 and 90, okay? Technically speaking, how do we do this? Technically speaking, how do you find the average of 2 numbers? You add them together and divide by 2. So if you went ahead and did the math here, that is 170, and 170 divided by 2 is 85. So we're going to use that idea that we're very familiar with, the average of 2 numbers, in order to construct the midpoint formula. Because it's a formula, but it should be very logical to us. So what we're going to do, since the midpoint is the middle of 2 points, we're going to be looking at the middle of 2 ordered pairs, okay? So what are we going to do? We're going to take the x values, add them up, divide by 2, as well as the y values. And that will give me an x coordinate and a y coordinate that will be in the middle of whatever 2 points I'm looking at. Okay. All right, so I hope that feels a little bit logical to you. So this is a formula you need to get to commit to your memory, okay? You can memorize it, but if you understand the meaning of it, it will be easier to remember. We're going to now look at the distance formula, which is a little more complicated, but hopefully we're going to attach some logic to it as well. Okay, so let's start easy. If we were trying to find the distance between 2 points on a number line, for example, just a plain old number line, right? How would you find the distance between these 2 points? You would subtract that, right? 6 minus 2. I'll give you these 2 numbers are 4 spaces apart on a plain old number line, okay? So we have to subtract our values, okay? So for example, we're not just going to be finding the distance on a straight linear x-axis number line. We are considering 2 points using the x-y axes. So we have x coordinates to subtract, and we have y coordinates to subtract. Okay, so let's write that down. So we have to subtract our x's, and we have to subtract our y's. Only there's a bit of a complication in doing so, because we are looking at 4 quadrants where some numbers are positive, some numbers are negative. Here's what could happen. if I subtract the x's, I might get a negative number. So let's say, for example, I got a -4 here, okay? And let's say when I subtracted the y's, I got a +4. If I add those two values together, I get a 0. When I know I'm looking at 2 points that are not the same point, they're not 0 spaces apart. So getting a negative value kind of throws a monkey wrench in it. So we need to counteract the possibility of getting a negative. How do we counteract that? We square it. So if we square both of those, we're not, because when you square a negative, what do you get? You get a positive value. Oh, but now the problem is we've made this number by squaring artificially high. So now we have to step back and say, well, how can I reverse or account for the fact that this number's too big? You got it. I know you all want to tell me that. Square root it. Okay. So this is the distance point. This is not D equals RT, right? That's if you're driving a car. That's a whole different story. This is the distance between 2 points on a graph. Okay. All right, so let's do a couple of these. We're going to use both the midpoint and the distance, and I'll write them back down here for us in case you want to refer to them real quick. Okay, so let's go with, what do we have here? Let's say we want to find the distance between -3, 4 and 2, 7. Okay, we're going to find the distance and as well as the midpoint. So let's go with the midpoint first. We're going to add our x values together. So -3 plus 2, divide that by 2. 4 plus 7, and divide that by 2. Pretty easy. We'll finish the arithmetic here. -3 plus 2 is -1/2. 4 plus 7 is 11/2. Okay. Now, I encourage you to quickly check our answer. How can I check this answer? Just in a general sort of way. Now you're going to see where I'm not a very good drawer again. I'm going to quickly graph these 2 points off to the side. -3, 4. Remember, left 3, up 4, so we're in the second quadrant. And where is 2, 7? That's in the first quadrant. Over 2, up 7. So here's a rough sketch. It's not great, it's not exact, but it's going to give me a rough idea if my answer is correct. Okay, so let's find the point -1/2, 11/2. Remember when we have an improper fraction and you're trying to find it on the graph, it might make more sense to actually change it to a mixed number. So 11/2 is 5.5. 11 divided by 2 is 5.5. Okay, let's try and find this point. So -1/2 is slightly left and up about 5.5 spaces. Again, I'm approximating, but hey, look, that looks about right. Okay, so I can have some confidence in my answer. I know I didn't come up with a point that was down here, which could clearly not be the midpoint of this little segment. Okay, so how long did that take me? Not long at all, to just sort of sketch it out, see if I'm approximately close, because my sketch is not exact, but I'm in the general vicinity, and visually it looks like it's halfway between those 2 points. Okay, pretty simple. All right. Let's take these 2 points and let's calculate the distance. How far apart are these 2 points? Now remember, these 2 points are on a bit of a diagonal, right? So I would have to say, when I find the distance, like if I straightened it out, how far on a number line would that look? Okay, so let's use our formula here. We're going to start with -3 minus 2, and then 4 minus 7. We have to square each of those. In fact, in this case, the way I have this written, both of them are going to come out to be negative. So we will square, it doesn't matter. Whatever they come out to be, the formula is square it. But the reason is to sort of counteract the negatives. So we get what? -5 squared and -3 squared. So -5 squared is 25. -3 squared is 9. Now here's the deal. These two numbers under this square root are being added together. They're not being multiplied. I cannot individually take the square roots. I must first add them up and then take the square root. So this will give me the square root of 34. I have a radical. Can I simplify this square root? Not 34. 34 only factors to 2 times 17. It does not have a perfect square factor. So, nice, kind of nice. That's as good as it gets. Okay, now, that's how you're going to give me answers, with the radical. But I want you to understand that this has a value. It's not just something we can't. The square root of 34 is between what two whole numbers? Let's say 5 squared is 25, 6 squared is 36. So the square root of 34 is approximately 5 point something. Okay? So these 2 points are a little bit more than 5 spaces apart. All right, so let's do another one. So let's say -2, 5, and 4, -9. And we're going to do both things here. We're going to find the midpoint and we're going to find the distance. So midpoint, add them up. -2 plus 4 over 2. 5 plus a -9. Watch your signs. So -2 plus 4 is 2, and 2 over 2 is 1. 5 plus -9 is -4, and -4 over 2 is -2. Okay. That's pretty straightforward, right? We're naming a point. So we come up with 2 numbers, right? We come up with an x coordinate and a y coordinate, which is different from when we're doing distance, because distance is just a single number. How far apart are these 2 points? Okay. All right. If I can, I'm going to try sketch my original points. -2, 5 over 2, up 5. 4, -9. Where is that? Right 4, down 9, approximately. Again, I'm just checking really fast to see if this gets close to looking visually like it's in the middle. All right, my picture's not perfect, but we're just getting a general idea. So I'm going to find the point 1 over 1 and down 2. Oh, there we go. Okay, again, I don't have a perfect picture, but this is very close to the middle. Right? Visually, it looks very close. So I'm pretty satisfied with what I have here. All right, on to distance. So we're going to take x, -2 minus 4. We're going to square that value. And 5. Now again, watch our signs, right? I have to subtract a -9. So subtracting a negative means I'm going to add it. All right. Here we go. Oh, I got some big numbers here. So this is -6. I'm going to go ahead and square that. I know -6 squared is 36. And this is 14 squared. Oh, I did this already on paper. That is 196, 14 squared. Okay, and now I have to add these two numbers together. So that is the square root of 232. Ah, big number. All right, it's a radical. Check on your calculator. Does 232 have a nice even square root? That would be great. Unfortunately, it does not. So we are left with simplifying this radical. I do not know the factors of 232. So I'm going to check if 4 goes into 232. Okay. So does 4 go into 232? It does. 58 times. So 232 is 4 times 58. Why did I check 4? Because it's the first perfect square. Okay, so I'm going to take the square root of 4. Can I simplify 58? 58 is an even number. 2 times 29. No. So 58 does not have any perfect square factors. So in simplifying this, we kind of got there really quick because 4 was the only perfect square factor. So take the square root of 4 out, leave in the square root of 58. Okay. Again, your answers will be given with radicals. Okay. But just know that this represents a number, a value. It's going to be a decimal value, right? The square root of 58 is between 7 and 8. So 7 point something times 2. So the distance between these 2 points is maybe around 15 or 16 spaces. So if I were to flatten this out on the number line, they would be about 16 spaces apart, more or less. I'm just guesstimating there, okay? All right, so we have the midpoint formula, we have the distance formula. They need to be committed to memory. I hope that this one's easy to remember because it should just be the middle of the x's and the middle of the y's. That's pretty logical. Again, this one, maybe more thought to it, right? To find the distance, you would subtract. So we subtract our x's, we subtract our y's. To counteract negatives from that, we square each value. And then to counteract the squaring, we square root it. If you get a number at the end like this, you may have to think about simplifying that radical, which we have talked about. Okay? All right. Have a good day.